that hurt. Here we go. We left off after doing a little bit of this function business. Let's see. I know we did enough through 4. Did we do 5 and 6? We hadn't gotten there yet. Okay. So we were getting close. Really?
You gotta share.
Gotta share. He's giving him out. Oh, is he? Yeah. You...
Okay. Wait, are you legit just giving people cookies?
Yeah.
Huh, good on you. Okay. We did function stuff. Remember, you got to pick the numbers to put in the table, or sometimes the numbers are already given to you. In fact, that's what we were doing before. Remember, they always gave us the numbers. I want to go back before we do the next few, because they can get tricky. I want to go back and look at numbers 3 and 4. Tell me what you notice about the numbers they chose to put in the table. Because this is a way that you cannot get gross numbers. What's up?
So there's always a 0, is what I'm noticing.
Okay.
And then sometimes there's like -1, and then they have the opposite of that as 1. Or they'll have like -16, and they'll have the opposite of that as 16.
So we want 0, we want positives, and we want negatives. So we can see on both sides of the graph. Good. What else? Like, why did number 3 choose -8, -4, versus number 4 chose -6, -3? That wasn't just because. There was a reason for it. Why do you think?
Because you're doubling it when you do it. Because when they did -1, they went to -2 because they doubled it. And just like these, they did -3, and they're doubling it to -6.
Okay, not necessarily double, but you're really sniffing down the right trail there. But then, sometimes they go further. ×3, ×4, ×5. They're multiples of. That's the catch. Right next to this, big honking letters. This is important. If you choose the numbers and there's a fraction, they chose multiples, mo. I can spell, I swear. Multiples of 4. You notice that they were counting by 4s? -8, -4, 0, because 0 is the easiest number to work with, 4, 8. If I wanted more points, I would choose 4, 8, 12, 16, 20. The reason I'm choosing multiples of 4 is because if I take 4 divided by 4, if I have 3/4 times 4, well then 4 divided by 4 is 1. 1 times 3 is 3. Then 3 minus 2 was 1. I ended up with a nice number. If I don't, what happens if instead of choosing these numbers, you know what, actually I'm bringing up a calculator and I'll show you the table. If I don't choose numbers that are divisible by 4, then I'm going to get some ew. No, put that down. Yucky. Right? Okay, if I come over y is clear. And it was, what was it, 3/4 x? 3/4 x minus 2? Oh wait, no, that's still in ask mode. Okay. If I don't, look at what happens if I put in 1. Hey, I said get rid of that. Listen to me, Frank. Okay. Look at the numbers in between. Look at ew, fraction, ew, fraction, ew, fraction. Oh, hey. And if I keep scrolling down, if I go to 5, 6, and 7, yuck, gross, nasty. I get to another multiple of 4. Oh, hey. That's why I'm choosing it. Okay, what was the next one? X over 3 plus something? Or just negative x over 3, okay. This right here is taking a number and dividing it by 3. Y'all got a calculator? Y'all got a calculator? Y'all got a calculator?
I was trying to tell everyone to take out a calculator.
Thank you, Captain Obvious. Y'all ever look up Captain Obvious GIFs?
No.
They are amazing.
No, but
Captain Obvious was a dude, like commercials years ago for like a travel company or something. It was this dude in this just god awful like red captain's jacket, and he. But Captain Obvious GIFs, they are the best reaction GIFs you will ever find. They're wonderful. But thank you, Captain Obvious.
What kind of gifts are they?
Reaction GIFs. So if I just type in Captain Obvious mic drop, and it'll be like, and he walks off the screen. It's great. Like, anyway. This is a number divided by 3. Y'all got a calculator in front of you now. Take, what's 1 divided by 3?
1. 3. What? 1/3.
-3.
1 divided by 3, not 3 divided by 1. 1/3, or point bunch of 3's. What if I'm trying to do this and I'm putting in numbers that aren't divisible by 3? What if I put in 7? 7 divided by 3. 7/3, or 2.333333333333333. I don't want to graph that. I don't want to write that in my table. So instead, because I saw a 3 on a denominator, I'm just going to count by 3's in my table, because then I know they're going to come out nice. Please, this is a big deal. This is going to save us a lot of hurt in the next 2 months. If I ever see a fraction and I have to pick numbers to put in the table, I want to pick numbers where I'm counting by that denominator. It's going to save you such a headache. All right? They chose multiples of 4. They chose multiples of 3 because that was the denominator. So,
Wait.
Did it?
Don't you dare.
Joke.
come on, finish writing. Feel like the evil monkey from the Family Guy. So, I hate that show. God. I take that back. The first 2 seasons were great. Then they got canceled.
Wait, what?
Family Guy.
Oh.
The first 2 seasons were great. Then they got canceled. Then they came back like 10 years later. And now they've been going for like 15 years or whatever. So.
I hope they not got canceled a second time.
It's like The Simpsons.
It's so stupid, but people love it.
The Simpsons used to be decent. Simpsons changed their mode of humor to match kind of the Family Guy South Park model.
I like South Park.
Dude, those shows.
I like Family Guy more than South Park.
Early to mid 90s Simpsons is where it's at. But That's not in any way, shape, or form nostalgia speaking. Y'all got it?
No, I'm still finishing up. I like South Park together. Okay, no, I'm what? I'm joking.
Okay. So let's go over here. When I go to this 5, number 5 says x over 2. Because there's a 2 on a denominator, I should choose numbers for my table that are counting by 2s. And just like Landon said, I'm going to want to put 0 in the middle and have positives and negatives just to see what happens on both sides of the graph. So I'm going to choose 0, 2, 4, 6, 8, 10, 0, negative 2, negative 4. Okay. Now you can do this by mental math. You can do this written out in a table. You can press buttons on a calculator. I don't give a flying fornication what you do. We're going to have x. We're going to have x over 2 plus 4, and we're going to have y. And if I plug in, here we go, something over 2 plus 4, something over 2 plus 4, something over 2 plus 4, on and on and on and on. If I'm plugging in the numbers negative 4, negative 2, 0, 2, 4, and on, well, stick a negative 4 in there. What's negative 4 divided by 2? Negative 2 divided, not times. So negative 2 plus 4, 2. Stick a negative 2 in there. What's negative 2 divided by 2?
1.
Close.
Negative 1.
Negative 1.
Oh.
Plus 4. If you're just going to say random stuff, just stop. Okay? What's negative 1 plus 4? 3. Okay. Stick a 0 in there. 0 divided by 2.
0, 0.
Plus 4.
4.
Do you see the pattern?
Next will be 5.
So 2, 3, 4, 5, 6. Now I get to plot the points. Negative 4, 2. Hey, it's been a few days. What if I don't remember how to do these? That handy dandy cheater that we kept writing next to our problem. X, then Y, with what positive and negative means in terms of your direction. So tell yourself, negative 4, 2 means left 4, up 2. Left 4, up 2, and make sure that's actually where it goes, because look at the scale.
It's kind of funky. It is kind of funky.
What are they going by on the X? What is every box worth?
1.
1, right? 1, 2, 3, 4. Okay. What about the Y's? They're also going by 1s. They just made the box a little bit taller so that we could see more of the graph. Stick in a left 2, up 3. Left 2, up 3. No left or right, up 4. Right 2, up 5. And right 4, up 6. What should I be doing now? There you go. Get yourself a straight edge. No wing it. Bad wing it. Hi.
If we ever have a number that says below, like if they cut it off, do we put that in?
We're going to talk about that, what happens when it's not like there's no room on my graph. If it's 1 or 2 off of the graph, we'll go off-road and just kind of wing it. But if it's way off, we'll just won't do that one. Connect your dots. Now, y'all remember, you don't have to write this part out. I severely overkilled what I wrote on here. There is nothing wrong with writing this. Shut your holes. Thank you. There's nothing wrong with going to your main screen, clearing out stuff that scares you, and saying, couldn't I just have a fraction and say -4 over 2 plus, what was it, 3? Plus 4. There we go. Just type it. There's nothing wrong with letting the calculator do the work for you. Okay? Let the calculator do the work for you. It's been about 2 weeks. Should we update Mom Bear on how things are going?
Not really.
Do we want to change our behavior right now so that that report can be a little bit better?
Yes.
All right. So, I would like you to pick numbers right smack in the middle of here. See how there's nothing underneath? There's no denominator. So I'll pick nice, easy numbers in the middle. Okay, just like Landon said, if we stick to the middle of the graph, and if we have a 0 in there, we'll probably find numbers at work. Plug them in, plot the points, draw the line. What? What, who, where? What about them? Your x's. You have to plug that in. You're going to do 6 times a thing minus 7 to get your y. So you got a calculator. What's 6 times -2? Minus 7. And then take that, minus 7. So that's not going to fit on our graph. Do it again. Keep going. Ew. Do it again.
So, just minus 7.
Do it again. Because so far, none of these are fitting on the graph. Put 6 times 1. Just 1.
And then minus 7 would be.
Oh, you were saying minus 1? Okay, yes. You see the pattern, right? Go up 6, up 6, up 6.
Yeah.
What's up 6 from there?
5.
There you go. So these couldn't even fit on my graph. But these do. 1, negative 1. Where's the next one?
5, 2, and then line through.
Connect the dots. There you go. Okay, it turns out the numbers that I put up there, a good chunk of them don't even show up on the graph. This is why we pick a bunch of numbers. What's the problem? Leaded or unleaded? Will you say you were iPhone?
Confused.
Then you should say that. You're taking 6 times a thing minus 7 to get the y.
Oh. So,
So,
like, is 6
what's
times
6
negative 2?
is?
Negative 12.
Okay, minus 7.
Negative 5.
No,
Or 5.
no. You owe me $12, you borrow another 7.
Oh.
You go further in the hole, right?
19.
Do it again. 6 times negative 1.
Negative 6.
Minus 7.
1. Or 0. Cannot think right today.
Then use a calculator. I don't care. My room is not a do it in your head or else. Use your calculator. Minus 7. There you go.
Oh, okay.
Do that for every one of those, and whichever ones fit on your graph, put them on your graph.
Thank you.
Okay? I hope we're getting this through our head. You got 3 teachers. Ask questions. There you go.
I don't understand this.
You're doing it right. If you shove a 0 in there, what's 6 times 0?
0, so is that negative 7?
Negative 7. Yeah.
That was 7.
Okay, now this doesn't fit, right? We don't go down that far.
No, none of this fits.
Doesn't fit, but... Oh, hold on. What's 6 minus 7? You have $6. You want to buy a $7 lunch.
Negative 1.
There you go. So just move this guy down there. And then you already have 2, 5. Use a straight edge. Use a straight edge, you bum. That is right. You got her?
Yeah, I didn't see
You actually got her? Okay. I'm going to test you.
I used my.
Oh, yeah.
My brain's not working.
If you're going to do it right. Okay. You had the numbers? Yes. You got your calculator on hand? Okay. Take 6 times negative 2. Subtract 7. Ta-da.
You can't fit
Is
it on the graph though.
But it doesn't fit, so you got to keep going. Not all of the points that we choose are actually going to show up on the graph they give us.
Oh.
Sometimes they're way off-road, and you just have to keep guessing until you get enough points to make the graph.
Oh.
Okay, try again. 6 times negative 1. Minus 7. Also, not on our graph. Keep going until you hit them that works. There's only 2. Okay. Okay. Looked like we either got there or we got frustrated and stopped doing anything, and then maybe if you asked a question, you got it figured out, and you're like, oh, wait, that ain't too bad. Okay? I'm going to take a bunch of numbers and plug them in right here, and that's what gets me my y's. So I take 6 times negative 2. Poke, 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 enter. Negative 12. Minus 7, enter. And you get? And you keep doing that. Just keep plugging the numbers in. Let the calculator do the heavy lifting for you. My job is to make sure that you can graph the line. I don't care if you can do basic arithmetic. That's not my job anymore. My job is to give you the tools to do the thing we're supposed to do. And then you get negative 13 and negative 7 and negative 1 and 5. And then I go to plot some of them, and Kai starts drawing like evil death face, murder pen, because that doesn't fit, does it? That doesn't fit. And that doesn't fit. But 1, negative 1 does. And 2, 5 does. Do I have at least 2 points to create a line? Okay. That's actually called an axiom in geometry. That by definition, a line consists of any 2 points. Axioms and postulates are things that you can't actually prove. You just have to accept them as true because friggin' look at it. Okay? There are some things that you can't prove. You just have to look at it and like, well, duh. Okay? And 2 points makes a line as one of them. Now, we run a risk with this. Dylan, we goofed a negative, right? So Dylan had this point, but then we just missed a negative and had this point. Dylan's line would have been a little bit off. That's why if we can, we want 3 points. In this case, we didn't have enough room to fit 3 points. Oh well. We just had to do 2 and hope for the best. But this is why we want 3 points, because if one of them was off, it screwed up the whole thing. Okay? It's also why we want to double check things with calculator. Check your arithmetic. That's why, what?
Is it yellow or the purple one?
Yellow's the correct one. Like, I'm just showing that would have been off because we just missed a negative. Now, if we had 3 points, let's say we were able to make, let's say we were able to make a third point that was like at this fraction spot here. Well, if I had that point and then this, I would see that it kind of, like, that ain't right. So I must have goofed something up. Okay. Yes, sir.
So actually, for the purple one, the over 2 up 5 one, that would actually be wrong if he did it wrong. Because he would have gone over.
It wouldn't line up with what we should have had.
He would have gone over.
It's kind of like if you're going to screw up, you want to screw them all up kind of thing. Okay. So That's why, and we're gonna get that. We do that in Algebra Half right now. We're going to see it again when we review equations. When I ask them, well, what do you move first? And the answer is there's 4 correct answers. It doesn't matter, you just move something. Okay, and that's from back in my coaching days. I had said, I don't care if you screw up.
What did you coach?
Just screw up going 100 miles an hour and hit someone.
What did you coach?
I coach football and track. But then I gave it up because I can't stand the parents. Because everyone thinks their kid's a rock star when they're really not that good. Okay, just now at the middle school level, like I coach middle and high school. At the middle school level, yeah, I'm gonna play every kid. Do you want 5 kids who really know what they're doing, or do you want 25 kids who all have participated and know what's going on, and then they hit puberty? Because in middle school, let's be honest, the kid who hit puberty first, they win.
Oh, yeah. Yep.
Right? We had 2 kids on our 8th grade team, twins. They're man-childs. Holy crap. They're like 6'2". They have like 6 packs. Like in 8th grade? When you got little Timmy over here that's only like 4.5 feet tall? I'm going to run him over. You're going to break something.
He had a super high voice.
Oh, yeah. So, all right. The word problems. You're like, oh, no, words. Yo, yeah, get back over there. Yeah, words. Okay, we're going to words. These are linear equations, and I think I said this last time too, that these are really exemplary of the type of problem you'll see in the real world. In the real world, it's very common in terms of purchasing things that you have to pay a fee and then a rate. For example, this time of year, how many people are turning on their furnace for the first time and, oh, it don't turn on?
Oh,
Uh-oh.
tried it to work,
Okay.
Just get an extension cord.
What'll happen is someone doesn't follow the directions on the front of the furnace that says you should clean the sensors every spring after they got a bunch of dust on there. You should clean them again in the fall. That's it. Like you could take one of those little air cans, done. But they don't do that. So then their furnace doesn't work. So then they have to call an HVAC technician out there, and he charges them $100 to show up to the house. And then he's going to charge $75 an hour for labor to walk in, read the directions on it,
And sit there for an hour.
and because they charge by the hour and it was only part of an hour, it doesn't matter, I'm still charging you for the whole thing. You just got a $175 bill plus tax because you didn't read the directions. This type of equation is very common. For every service call, the plumber is going to charge you $75 just to get out to your house. And then $100 per hour. Okay? Technicians get paid because they have the individualized skill that you don't. There's stuff that, yeah, I can do it myself. I don't have time. I'm going to pay the guy. Or there's stuff that I could do myself, but I'm a little sketchy on it. When I put in my water softener, all the like beads of goo around the couplings on the back, and like, y'all, it ain't pretty. It works, but it ain't pretty. Now, will I pay someone who knows what they're doing to come do it so that it's done right? Yes, but I'm going to have to pay for it. Really pay for it. Make a table, graph the function. How much would you pay for a service call that took 4 hours? So let's start with the table. 0 hours. I don't want purple there. Purple bad. Yellow. There we go. 0 hours. How much does it cost when the guy just shows up? Right? It's the cost of 0 is 75 plus 100 times 0. Well, 100 times 0 is 0. 0 plus 75 is, just like Kevin said, 75. Then if he's there for 1 hour, what's 100 times 1?
100.
Plus 75.
175.
175. Then he's there for 2 hours.
200.
Plus 75. 275. And then you see the pattern, right? When he's there for 3 hours. 375. Can you plot those points? 0. Oh, where is 75? They didn't write it.
I go fill in the words.
Finish this one off and then yes.
Put it halfway through.
Halfway between 50 and 100, right? So at 175, where's that going?
In the middle, 200 and 150.
Between 200 and 150. Keep it going. Put in 2 and 3. Put them in. So 2, 275, 3, 375. Use your straight edge. Now, 4 hours runs off-road. It runs off the graph. But because I know how the equation works, how the function works, I can say the cost of 4 hours is 75 plus 100 by 4 hours. How much is it going to cost? 475. 475 what? Okay. I got to ask. 475 what? I had a guy who fixed up the welds on my plow last week after all of that mess. I cracked the welds on my plow. Sheared a bolt clear off. 3/4 inch bolt. Sheared it right off. Okay? That stuff was so heavy. I went and paid a guy to fix it because I don't got the equipment to fix it. It was dirt cheap though. He only charged me like $55 and he redid all the welds on it, put a new crossbeam on it. So
Who is this person?
it's just a machine shop in Bell. But yeah, super. I was expecting like $300.
You're gonna show us the address to this place.
Okay, I will happily do so. He was a nice guy. I gave him an extra $50 and said, go get a couple cases of beer. Have a good weekend. Okay, like the dude was nice. He did me a solid. He, instead of charging me this much, instead of charging $100 an hour for the shop fee, he took a bunch of pictures of my plow so that he could recreate it because it's literally a one of a kind in the state, and now he's going to make money building them. So, it's a rear-mounted plow.
Oh, so that's why it was so cheap.
It's on a cart, slide it into the receiver hitch, take the strap off it, hit the remote, boop, off I go. It's pretty nice. So, yes, because we are there. We're at number 8. Number 8 is the skills, concept, problem solving, the assignment part. So I promised you that we would do this. We finished off 1-7. We only had a few left. You have the remainder of class, and that is a boatload of class, to do this assignment. When you are done with this assignment, yet again, I'm going to caution you. Go back and make sure that you have everything done. Everything in this packet except for Progress Track 2 should be filled in. Okay? Now, if you're like Gavin, who dropped it off with me and then life kept freaking happening and I never put it in the gradebook, now would be a great time to finish that stuff off and put it in a pile so I do it over the big long weekend. Okay?
I wish life wouldn't happen sometimes.
right? So, what's up, Kip? Yes. I'm cool with you jamming out while you're working. What I don't want you doing is dinking around on your phone and saying, I'm finding something to listen to. Okay? I guarantee the whole lot of you got a station or a playlist. You can just hit play, throw it in your pocket, keep going. Okay? All right. So you have the remainder of class to work. Once you're done, you're done. Make sure everything else in the packet is done if you were one of those kids who didn't have things taken care of. And then that's it. No homework for the weekend. Until you hit the stop sign, whatever that is on the next page. So, yes.